So there is another research which is given by the great physicist Rutherford on alpha particle. This is the source of alpha particle in emitting a light or alpha rays on a thin gold foil, and automatically this is distributed in different direction. This is called scattered particles. So this one here, it's undeflected particles, and this is more deflected particle, and this is controlled by a circular fluorescent screen. So this is your Rutherford model where the alpha particle is released and it is scattered in multiple directions. So an alpha particle is a positively charged particle having a mass equal to that of helium atom, and positive charge in magnitude equal to the twice of the charge of an electron, and they are emitted by many radioactive elements. The scattering of alpha particle provide useful information about the structure of the atom. You are able to see the alpha particle is passed and scattered, and this is viewed by the scintillation viewer, and the environment is vacuum. So this is the experimental arrangement. A fine pencil of alpha particle was obtained from your radioactive materials like radium or radon. By placing it in a lead box with a narrow opening is given. The alpha particle are emitted from the source in all possible directions, but only a narrow beam emerges from the lead box. So the remaining alpha particle are absorbed by the lead box itself. After passing through the D1 and D2 diaphragms, a narrow beam of alpha particle incident on a thin gold foil, and it is scattered in different directions, which can be moved or viewed through microscope. And there is a covered box which is made up of zinc. It's a zinc screen. So as specified, it's a zinc sulfide screen. The scattered alpha particles strike a fluorescent screen, which is nothing but coated with the zinc sulfide. When the alpha particle strikes the screen, tiny flashes of lights are produced. The observation can be made with the help of low power microscope. So this is how Rutherford alpha particle scattering experiment is done. So most of the alpha particle travel through the foil with the undeflection option. The atom is mostly empty space. It's the interpretation. If some alpha particles are deflected by a small angle, the nucleus is positively charged, as is the alpha particle. Occasionally, an alpha particle travels back from the foil. This one. The nucleus carries most of the atom's mass. That's how the experiment is done. So as indicated, this is how the Rutherford model is done. The circular detector and the alpha particle is passed, deflection is happening. So most particles pass through the straight and some are merely deflected. But surprisingly, very few bounce back. The result is majority of the atom is space. But a few hit, they're very small, and it's because of the atom nature. This is how your Rutherford alpha particle scattering experiment is done.